Hello everyone, welcome to Mission for Excellence. Today we will do Fourier sine and Fourier cosine transform. So first let us define Fourier sine transform. So now the Fourier sine transform for a function ft where t lies between 0 to infinity is denoted as f bar s. We write here suffix s for the sine transform, that is equal to Fourier sine transform of the function ft equal to integral 0 to infinity ft sine st dt. As in the last video we did the Fourier transform, or you can say Fourier complex transform or Fourier infinite transform, in which we have taken the minus infinity to infinity and ft e raised to power minus iota st dt. Now you know that this e raised to power iota theta, e raised to power iota theta is equal to cos theta plus iota sin theta. So this Fourier transform, complex Fourier transform, is divided into two parts. First Fourier sine integral and Fourier cosine integral. So this minus infinity to infinity will be also converted to 0 to infinity, as we are taking only the half part of that. So that's why the Fourier sine transform is 0 to infinity ft e raised to power minus st sin t dt. And the inverse formula. So as we define the Fourier sine, simultaneously we define the inversion formula for Fourier sine transform. Inverse formula. In the inverse formula we will calculate ft. So we write here ft is Fourier sine inverse of f bar s. This S denotes the Fourier sine transform, equal to 2 by pi integral 0 to infinity f bar s sine transform sine st ds. The integral will be with respect to s in the inverse transform, and in the Fourier transform the integral is with respect to t. So this is the Fourier inverse formula for the sine transform. Similarly, when we define Fourier cosine transform, Fourier cosine transform, in this we will take cos st instead of sin st. So the Fourier cosine transform is denoted as f bar cs. Ultimately it will be the function of s, that's why this is a function of s, and this lower s denotes the Fourier sine transform. Here also this is the function of s, and this lower suffix is known as the cosine transform. That is equal to Fourier cosine transform of ft, and is calculated as 0 to infinity ft cos st dt. So in this we take cos st. See, in the similar manner we define the inversion formula. Inverse formula. Inverse formula, we take ft is equal to Fourier cosine inverse transform of Fourier cosine transform, that is equal to integral 0 to infinity fc bar s cos st ds, and we take here 2 by pi. So this is the Fourier sine transform and Fourier cosine transform. As we discussed in the case of Fourier transform, the product of the coefficient of the integral must be 1 by 2 pi. So if we take 1 in the Fourier transform, then we take 1 by 2 pi in the inverse. If we take 1 by root 2 pi in the Fourier transform, then we take 1 by root 2 pi in the case of inverse Fourier transform. Similarly, in case of sine and cosine transform, the product of the coefficients of integral must be 2 by pi. So if you take the Fourier sine transform, then if you take here 0 to infinity and the function sine st dt, then in the inverse transform you must take 2 by pi. So 0 to infinity ft sine fs sine st ds. So similarly, in this case, if you take here 2 by pi under root, then also we take here 2 by pi under root. In the similar manner, if you take here 2 by pi, then we take here only 1. It means the product of these two terms, you can take 2 by pi and root 2 by pi and root 2 by pi in both, or you can take 1 and root 2 by only 2 by pi, or you can take 2 by pi and 1. The product must be 2 by pi. So in the similar manner, we define the inverse cosine transform also. You can opt any of the choice. Now let us do one question based on Fourier sine and cosine transform. Find the sine and cosine Fourier transform of 2 e raised to power minus 5x plus 5 e raised to power minus 2x. So first let us calculate Fourier sine transform. So now by the definition, first we take fx as 2 e raised to power minus 5x plus 5 e raised to power minus 2x. Now from the basic definition, the Fourier sine transform of this function is 0 to infinity function fx into sine sx dx. We are using the main definition. Now we put the value of fx here. So value of fx is 2 into e raised to power minus 5x plus 5 e raised to power minus 2x. We will put this value here. So now we will get integral 0 to infinity, put the value of fx, 2 e raised to power minus 5x plus 5 e raised to power minus 2x sine sx dx. So now let us separate the two integrals. So we get twice of 0 to infinity e raised to power minus 5x sine sx dx plus 5 integral 0 to infinity e raised to power minus 2x sine sx dx. Now to solve the integral, we will use the integral result, that is the integral of, using the formula integral of e raised to power ax sine bx plus c. This is the standard result we have derived by using the integral by parts. So this e raised to power ax sine of bx plus c dx is equal to e raised to power ax divided by a square plus b square into a sine bx plus c minus b cos bx plus c. We will use this formula here. So now comparing this with this, we see e raised to power ax means here value of a is minus 5, bx plus c is sx. Here also e raised to power ax is a is minus 2 and bx plus c is again sx. So now let us use this formula for this integral. So let us write here. We get Fourier sine transform as twice e raised to power minus 5x upon a is minus 5 and b is s. So we get here 25 plus s square. A is minus 5. So minus 5 square is 25 into minus 5 sine sx minus s cos sx. This is the first part. And for the second part, we take 5 e raised to power minus 2x by 4 plus s square minus 2 sine sx minus s cos sx. So comparing with this, we get this result. So when you put the limit is 0 to infinity. So write here limit 0 to infinity and 0 to infinity. So when you put the limit, you will get the result 2 e raised to power minus infinity is 0. So the whole term will be 0. When you put here 0, e raised to power 0 is 1. So we get here 1 by 25 plus s square. Sine 0 is 0 and cos 0 is 1. So we get here minus s, cos 0 is 1 and 1 for minus 4, the upper limit minus lower limit. Similarly, you will get here 5 into minus 1 by 4 plus s square into minus s. So the result will be 2s by 25 plus s square plus 5s by s square plus 4. So this is the Fourier sine transform. Now let us calculate Fourier cosine transform. Second part, Fourier cosine transform. The function fx is given as 2 e raised to power minus 5x plus 5 e raised to power minus 2x. Now from the basic definition again, the Fourier cosine transform. So we use the suffix c here. Fourier cosine transform is integral 0 to infinity fx into cos sx dx. So now put the value of fx, we get integral 0 to infinity 2 e raised to power minus 5x plus 5 e raised to power minus 2x cos sx dx. So now we will use the formula. First we will separate the integrals. So we will write here 2 0 to infinity e raised to power minus 5x cos sx dx plus 5 into 0 to infinity e raised to power minus 2x cos sx dx. Now we will use the formula integral 0 to infinity, integral e raised to power ax cos bx plus c. Just as previous, we have defined the formula for sine. This is formula for cosine. E raised to power ax, a square plus b square, a cos bx plus c plus b sine bx plus c. So compare these two integrals with this formula. We will get, after putting the limit, we will get twice of 5 upon 25 plus s square plus 5 into 2 upon 4 plus s square. So this is 5 to the 10 and 5 to the 10. We take 10 outside. So this is 1 by 25 plus s square plus 1 by 4 plus s square. So this is the final result. So this is the Fourier cosine transform. Hope you like the video. If you have not still subscribed my channel, please subscribe and click on the bell icon so that you can get the notification about the latest video.